Starting in elementary school, we've all been taught that the Earth is a globe. The moon orbits around the Earth around the sun, and so on. There are some people who don't believe this though, and it may surprise you to know how much popularity flat Earth theory has gained in recent years. A 2018 survey of 1.8 million adults in the US found that 16% harbor doubts about the Earth being round. Let's suspend our disbelief for a few minutes while we delve into the following question. What if the Earth were actually flat? There are a lot of different groups of people devoted to debunking round Earth, but they don't all agree with each other regarding its true form. Several flat Earth maps have been proposed over the years, and they all have distinct variations. According to the Flat Earth Society, this map depicts a popularly, though not universally, accepted model. As you can see, it's shaped like a disc with the North Pole at the center. Antarctica is depicted as a wall of ice around the outer edge of the disc. If the Earth were shaped this way, then what would change? Let's start with gravity. Many flat Earthers do not believe that gravity is pulling us down, but that Earth is traveling upward and we're being pushed down by its inertia. Think of it like riding in a car. When the car is traveling at a constant speed, you don't really feel like you're moving. But if someone steps on the gas, the car's sudden acceleration will push you back into your seat. Flat Earthers' theory of universal acceleration works in the same way. It states that the Earth and other large celestial bodies are being propelled upward at a rate of 9.8 meters squared per second, and we are held down by the inertia. For those who don't believe in universal acceleration, let's think about flat Earth's gravity instead. In basic terms, gravity can be defined as the force of attraction between two objects. Objects possessing a greater mass have a stronger gravitational pull than those with lesser mass. In a disc-shaped Earth, the center of the circle would be surrounded by the greatest mass, so it would therefore have a stronger gravitational force than any other spot on the disc. This means that everything would be pulled towards this central point. What would this mean for humans? Well, if someone stood at the center of the disc, gravity would pull them straight down. If they stood away from the center, they would still be pulled back towards that same spot. As they traveled further away from the center, they would begin to feel stronger and stronger effects from the gravity pulling them backwards. It would feel like they were climbing a hill that became steeper and steeper the further they climbed. By the time they neared the edge of the disc, it would be the same as trying to scale a vertical wall. If they managed to climb over the edge, the center of the disc would be underneath them, so gravity would once again pull them straight downward. Because of the altered direction of gravity on a flat Earth, most if not all of our buildings and bridges would crumble. Some structures near the center of the disc, where the horizontal gravity is weakest, might be able to remain standing. Buildings nearer to the edge of the disc, such as South America on the proposed map, would not be able to withstand the horizontal pull of gravity. Plants would also grow quite differently on a flat Earth. Trees are able to survive thanks to a process known as geotropism or gravitropism. Their roots anchor them into the ground by growing in the direction of the strongest gravitational pull, and their stems grow in the opposite direction. This ensures that they are able to draw water from the ground and absorb sunlight for photosynthesis. It might seem like the roots are just growing away from the light, but that's not the case. Anyone who ever had to weed a garden can tell you that roots are very effective at holding on to dirt. Similarly, when trees are uprooted in landslides, their root systems pull huge clods of dirt along with them. At this point, something fascinating happens. The root segments that are still covered in dirt change their direction of growth to realign with the earth. Remember, these roots have never been exposed to light, so they have no way of sensing which direction to grow in order to avoid it. They grow in the direction they are being pulled by gravity. Plant stems, or in this case tree trunks, grow against the force of gravity. Flat Earth's gravitropism would cause trees to grow away from the center, so trees near to the center would grow straight, but towards the edge of the disc, things would get a little strange. In order to go against gravity, tree trunks would have to grow horizontally along the ground. However, it's pretty likely that we would never get the opportunity to see any actual sideways forests. That's because trees need water to grow, and all of the water on flat Earth would be pulled to the center of the disc where gravity is strongest. So we would have only one body of water, a massive circular pool right in the center of the disc. The ring of land just outside of the water would be the only habitable area for land animals and plants. Too close to the center, the ground would be covered by water, and too far from the center, the earth would be an arid desert wasteland. Even the Sahara Desert has watering holes and more than 90 major oases. But the desert on flat Earth would have no water at all. Every living thing needs water to survive, so the outer ring of the disc would not be able to sustain any life form. Many animals need both fresh and salt water to complete different phases of their life cycles. In the case of a flat Earth, all salt water and fresh water would be combined in the sole body of water. As a result of this, a very large number of species would not be able to survive that humans rely upon for food. Still, the single body of water would still have some tides caused by the gravitational pulls of the sun and moon. Most flat Earth models depict the sun and moon as being roughly equal in size, both much smaller than the Earth, traveling in giant circles around the North Pole. This would cause the tides to occur in a circular motion like a massive whirlpool. The disc-shaped model from the Flat Earth Society depicts the celestial orbits occurring in a clockwise fashion. So in this case, the entire body of water would swirl perpetually clockwise. If the sun and moon were just traveling in circles, this would not allow for different seasons, so the weather would be the same year-round. What about day and night, though? Flat Earthers say that the sun's light reaches only a limited area of the Earth at one time, much like a spotlight. Whilst it may explain how daytime occurs when the sun is overhead, and nighttime occurs when it's not, there are flaws to this idea, and the shadows would be messed up. Unlike a spherical Earth, the sun's rays would hit objects at the same angle, meaning the shadows of two identical objects in different locations of the Earth would be the same. Eclipses are much more difficult to explain. If you remember, a solar eclipse is when the moon blocks the light from the sun, creating a shadow on Earth, and a lunar eclipse is when the Earth blocks light hitting the moon, casting a shadow on the moon. If the sun and moon are on the same side of the Earth, then how would one of them be able to block our view of the other? Flat Earthers claim that the moon is traveling at a slightly slower speed than the sun, and solar eclipses happen when the moon is in between an observer and the sun. But many Flat Earthers believe that there is also a third celestial body in our sky, which they refer to as an anti-moon or shadow object. This object is said to orbit closely around the sun, and its shadow is what we can see during lunar eclipses. However, the shadow object itself has never been seen because Flat Earthers claim the sun's rays conveniently block it from our view, just like other stars that we can't see during the day. So, unfortunately, we wouldn't be able to see any Flat Earth shadows during a lunar eclipse, no matter how amusing the popular meme may be. One of the major problems we would face on a flat Earth is that artificial satellites would not be possible. Satellites work by traveling outside of our atmosphere at a velocity just fast enough to defy the downward pull of gravity, but not fast enough to escape its effect. This allows them to continue in that same direction at a fixed altitude in relation to our planet. If the Earth were flat, satellites would have to travel in circles around the North Pole, just like the sun and moon. The gravitational pulls of the sun and moon would make it impossible for satellites to remain on a fixed course. No satellites means no GPS. Without navigation, airplanes would not be able to fly, and traveling to other countries would be out of the question. So we would just have to rely on compasses then, right? Well, no. Compasses work by telling us which way is north, and they rely upon the magnetic field to do this. A flat Earth would not be capable of generating a magnetic field. Earth's magnetic field, also called its magnetosphere, is created by the movement of superheated liquid metal in the outer core around an inner core of solid iron. This reaction can only exist in a spherical planet, and not having one would be a much bigger problem than you might expect. The magnetic field we currently enjoy protects our planet from solar radiation, which occurs when the sun ejects plasma particles, also known as solar wind. If we were struck by the full force of solar wind, it would be capable of stripping away our atmosphere, bombarding us with cosmic rays, damaging our DNA, and causing cancer. Oh, and it would evaporate all our planet's oceans. This is what scientists believe happened to Venus, which long ago was covered by vast oceans. Venus is quite similar to the Earth in terms of both size and gravity. One key difference between the two is that Venus does not create its own magnetic field. Solar wind carries an electrical charge that our own magnetosphere is able to deflect, but Venus is not so lucky. Its water evaporated long ago, and it has no protection from solar radiation. This explains why its surface temperature is an astonishing 872 degrees Fahrenheit, or 467 degrees Celsius. To say that this is incompatible with life would be a ridiculous understatement. We can observe the Earth's magnetosphere in action by watching the stunningly beautiful Aurora Borealis and Aurora Australis, also known as the Northern and Southern Lights. These occur when solar winds come into contact with the magnetic poles at the north and south end of the Earth. It goes far beyond a simple light show. We are literally witnessing the magnetosphere saving our lives by keeping the Earth habitable. It's difficult to imagine what life would be like on flat Earth, or if it would even be possible. Yet there are thousands of people who claim to believe that the Earth is not a globe. The debate has spawned numerous websites, books, and documentaries, and it shows no signs of stopping. Of course, it's possible that some of the supporters aren't as serious as they claim to be. Remember Poe's law of the internet. Without a winking smiley or other blatant display of humor, it is impossible to create a parody of fundamentalism that someone won't mistake for the real thing. So, what do you think? Do you think the idea of flat Earth is ridiculous, or is the ocean really bulging and I need to get my eyes tested? Let me know in the comments down below, and thanks for watching.